Okay, so this is a video of my robot vision software for the US First Robotics competition. A really big problem for my camera is that whenever the robot moves, or the pneumatic compressor is on, the shaking causes the camera to lose focus of the target. There is a case in the while loop that compensates for this shaking. However, as you can see here, sometimes it doesn't work. Here the robot crashes into the bleachers. I'll speed it up so we can go through the resetting quickly. Take notice of how quickly the camera locks onto the target as it enters the view. The original search routine provided by National Instruments and First was simply unusable. It would take up to 8 seconds to find the target. This one takes less than 2. As you'll see, the case that compensates for the shaking of the robot practically blinds the robot as it's moving. Did you know the tiger beetle runs so fast that its brain isn't able to process the images it sees? I guess we found a new name for our robot. Here, the camera will be thrown a little bit off by the white light behind the target. However, the automatic recalibration kicks in and the camera is able to find it after a few seconds. Here, the shaking of the robot screws up the focus of the camera. However, it stops and readjusts. Now watch as Dr. Sass gets out of the way to avoid being roadkill. Okay, I think this is really neat. See the basket with the red bumpers in the middle of the screen? The triangular wave scanning function not only notices that it is the green on top, red on bottom distinguisher of the red lines, but it also notices that it is the biggest area of any other target of the 4 on the screen. The robot then adjusts its trajectory so that it is on a collision course with the basket. Here, the robot will crash into the basket. Notice how the robot readjusts its motor speed so it is still aligned to the basket. The robot continues to shove the basket, maintaining its alignment perfectly with the basket. I will now go back to normal speed as the round ends. The robot scanning function finds the target, confirms it's the closest in the right aligns, plans the trajectory, and as it collides into the basket, maintains perfect alignment. Isn't that neat?
Camera works perfectly.
Here, we're testing out the gyro. It's going to go forward, make a 180 turn, and then I'm going to throw myself heroically in front of the driver's station in a valiant attempt to protect it from the collision.
You may want to...
Here's the scoring mechanism. There are 2 pneumatic pistons which push up a basket and then a little spinny thing to ensure the balls go through.
Is it me or is that battery bait kind of like...
Okay, so the rest of this video will deal with the magic behind the scenes, the development system. The controls consists of 4 joysticks and a driver station. As for the microcontroller board behind it, there truly is a convoluted art to building these things. It takes weeks to get the last component on the board to fit perfectly in a tiny contained area, and you're not even seeing the bottom of the board. The signals also flow logically from the top computer to the Victors to the terminals, top to bottom. Here are some spikes and Victors that we have running to the side. Our computer is currently running 8 Victors and 3 spikes. Here's just some video of the tracking. Now watch what happens when the target is flipped. The camera immediately recognizes that it's a different alliance and begins to search for other possible targets that satisfy the pattern that it's looking for. Now you'll see how the camera continues to gaze off into a corner. It's actually extrapolating the most probable path of the target. This is one of my better ideas for the vision software. If a robot passes in front of the camera and blocks its view, the camera will make an educated guess on the current position of the target based on the movement of the target before being blocked. Cool, huh? It has a time limit though. After about 2 seconds, the camera will give up and try to find a new target. Did you see how quickly it found the target? This film is now the same test as before, only at a farther distance. Although the target is far away from the camera and perhaps only 2 pixels in its view, it is still just as easily able to find it as if it were just a few feet away. This is not a claim that can be made by the US FIRST and National Instrument scanning function. This clip is of the original tracking function distributed by US FIRST and National Instruments. The biggest design flaw with this scanning function is that the camera spends too much time on the outskirts of its view, instead of looking towards the center, the most probable location for the target. Thanks for checking out my vision video. Please check the rest of my inventions on my account.